So let me ask you a quick question, like before I start my session. Uh, how many of you have actually had a situation in the past that you lost money for a card fraud or a debit card fraud or a check fraud? In other words, yeah, I see a lot of hands raised. Yeah, so I was also a victim of a credit card fraud just like 3 months ago when my wife, when we were doing a shopping and she lost her credit card, and within a span of like a 5 minutes time, we have seen like a 5 or 6 fraudulent transactions, right? So fraud is a big challenge uh, for businesses and also for consumers and also governments likewise. So, before I start my session, I'm going to give you some backdrop. I'm going to talk about fraud, but I'm going to tell you a story. Tell you a story about a developer like myself. I have like almost like 15 years of a development background. How a developer constantly, relentlessly tries to actually help, like I said, all these institutions, banks and financial institutions to prevent fraud, right? Like I said, a fraud detection has emerged as one of the biggest concern for most industries, especially financial services and e-commerce, right? When you think about fraud, and when you ask me like why is it so important, like that developers and the organization need to address a fraud, right? Fraud is a big challenge because if you look at these numbers here, annually, total annual cost through fraud losses, the global losses, right, is around $5 trillion. It's such a big number. And you believe it or not, there's a lot of money involved in fraud. And when you think about like how much of 5 trillion is actually lost through credit card, right? And I tried to actually come up with a number for the US, not my number, actually based on the McKinsey report. It's around 27 point change billion dollars we are losing annually just in the US alone on through credit card losses. When you ask me if how much of that money is actually going towards anti money laundering, right? Around $25 billion we are losing annually just in the US alone. So fraud is a big challenge. Like I said, developers like so traditionally they have been actually trying to prevent fraud by building these amazing intelligent applications, right? And if you want to go back in time and just kind of like check like historically how this has been done, how developers have actually and the companies tried to address a fraud, right? Back in 1994, what I call a risk 1.0. In the beginning, they have used a simple rules-based techniques. For example, you have a rule that says, well, if the transaction amount is more than some amount, like maybe $10,000, for given a consumer or a customer, you block a transaction, right? That's a simply rules-based fraud detection. And then in 2010 and forward, right? And developers actually they have started using, like these big data analytics and predictive analytics and all these models to actually find anomalies in fraudulent transactions, right? That I call a risk 2.0. And now, by the way, we have actually an example solution around both risk 1.0 and 2.0. And that is actually if you scan this code, and it will take you to a GitHub link, and that's you have a complete code repository. One of our developer, his name is Ashwin, he built out this code from scratch, and that uses Databricks and MongoDB to actually prevent fraud. I strongly recommend you take a look at this solution. So although we have like solutions like this, right, rules-based, and we have a solution, and we have AI ML-based solutions, and why are we still losing money? That the numbers I showed you previously, those are the numbers, the current numbers, like the numbers as of 2023, right? Why are we losing money? So let's look into that. So there are a lot of challenges, right? One of that is data silos in an organization, right? It's like, for example, you have a fraud systems, right? Like a fraud is done like think about like a payment fraud, right? payment system, there may be too many of payment systems. Like for each payment rail, they have a different system. And each system, they have their own database. And in a situation like that, you have too many of data silos. Getting a comprehensive look of your customer is very difficult, which is crucial for actually preventing a fraud. That leaves a poor customer experience because if your transaction is fraudulent and you lose money, and that leaves a poor customer experience. And also, it's a reputational risk for our organization. And then number two, most of the organizations, right? Most of the organizations, they use a mixture of technologies to prevent fraud, right? So they use on-prem solutions, and they use the cloud solutions, they use the legacy tech, and they use some emerging tech. When you have a situation like that, you have a diverse set of technology ecosystem. Innovation is very tough, right? You cannot really innovate. Innovate meaning like you cannot actually address an emerging fraud method, right? Maybe a deep fake type of a fraud. That is something you cannot do that easily. That's not going to be like a live solution. You need to actually maybe spend like maybe 3 or 4 months to actually address a situation like that. By then you may have actually lost a lot of money there. So that's another challenge, right? And the third important thing is why are they still struggling? Why are we losing money? These fraud solutions are very costly. That's not easy to implement, and one, and two, they're not easy to manage. It takes a lot of money, right? Because you need to, like I said, when you have like these hybrid architecture, right? You need to have teams managing like both on-prem solutions, cloud solutions, and one team managing like maybe C# or a Java, and you need a different skill set to manage this thing. It's not easy. It's expensive, right? To make a change and also to manage. And that's another reason big organizations are very slow in adapting to new trends, and also they miss out the opportunities and they lose a lot of money for those reasons. So now, like I said, developers, they do not actually stop. They never stop, and they constantly try to innovate and come up with new solutions, right? And what they're doing now, they're trying to use the latest and greatest technology. Like I said, something like a generative AI, right? This I call RISC 3.0 solutions, right? RISC 3.0 solutions, everything beyond predictive and rules based, and like anything that you use in the Gen AI ecosystem, like vector search, that actually can be classified as a RISC 3.0 solutions, right? In this, what they're doing is they're actually trying to using both the structured data, unstructured data, and semi-structured data to kind of help improve this fraud detection accuracy further, right? So there is not single method or single approach would actually completely eliminate a fraud. As you know, the fraud actually constantly evolves. The fraudsters actually, they try to constantly come up with new schemes that actually needs a solution, right? Like pretty much like in the moment in real time. So let's today in this session, this is all backdrop. In this session, I'm going to talk about vector search, how you can actually use, right, as a developer. Some of you are like a developer like me, how you can think about solutioning a fraud solution, or maybe any type of a transaction monitoring type of a solution using a vector search, right? So let's spend a couple of minutes on generative AI. Why generative AI is very important in this problem solving. So using generative AI, right? Like as you know, you can actually incorporate structured and unstructured data, right? So one of the things that you can do with this is like you can actually constantly listen to social media signals and things of that nature, and stream the data and use the data to actually, find these anomalies very, very quickly. I'll give you an example, right? So for example, you're planning to travel to Europe on a business trip, right? And you posted on a social media, maybe LinkedIn or somewhere, guys, I'm actually attending this seminar in Europe, and so on and so forth, right? And then you go to Europe and you actually try to swipe your card and try to buy something there. You have a US credit card, but you are making a purchase in Europe, right? Traditionally, what we do is, because the request is coming from a different IP, different geographic location, the fraud solution tend to actually detect that and kind of prevent the transaction. that leaves a very poor customer experience, right? Because it's a legitimate transaction. It's a false positive. So in situations like that, you can use the social media data to constantly stream and use that to actually improve your detection accuracy. That's as an example, right? You can apply this to the other situations as well. And something like a transaction details, right? Let's say transaction details generally, can be like in a transaction note, so you can actually use that information to find out information about the particular type of a transaction. Like for example, if the transaction text contains anything relating to ISO 20022 or anything of that nature, standardization, you can use that metadata to actually infer some meaning that you would later on use it to prevent a fraud, right? And now let's work on an example. One of our developer in my team, his name is Paul, and he built a solution using vector search, and how you can actually use a vector search to find out a fraud. Now I'm going to talk about two examples here, like how you can use vector search to determine fraud, card fraud, and the second one I'm going to talk about is how you can use the same technique to prevent anti-money laundering. Okay, so before I actually give you an example, right, let me actually walk you through a scenario. Let's imagine there's a large e-commerce shopping company, right? And they wanted to find fraudulent activities on their website. The way they do that is, traditionally, the way they do that is to capture all the data, clickstream data, login data, anything that is around a person, right? A shopper who's trying to actually buy something online. All the clickstream data, profile data, social media data, and everything, they collect it in one place, and then actually they try to actually create predictive models to actually help prevent a fraud, right? And using a predictive modeling, right? Sometimes it works, sometimes it doesn't. In situations where it doesn't work is when the data constantly changes. Let's say, for example, you add a new data source, right? Think about it, like in a predictive modeling, right? How do you actually retrain your model to accommodate the new incoming data sources or a new signal, right? It's going to be like it's a time-consuming activity. That's something you cannot do in real time, in the moment, right? And also, if you have worked on Gen AI or predictive analytics, feature extraction is one of the difficult thing, right? It takes a lot of time. Right? Although there's some companies, they say like we can extract features, there's an online feature store and all that, but it still takes time, right? You may not be able to actually get this accuracy that they need through the predictive modeling, right? So, whereas vector search, you can actually take the incoming signal, incoming data, like from the social media, you can create a vector representation of that, adding other profile information, and you can use these vectors, right? The composite highly dimensional profile or the shopper profile, right? With all those attributes, right? With all those attributes that you typically use in a traditional analytics, plus the other ones, the structured, unstructured, and semi-structured. And you can use all that and create a vector embedding and use that vector embedding to actually find out if this is a fraudulent or not. The way it is done is like I said, in the shopper example, as a shopper actually, he browsed through the website and you collect all the information. A good developer actually collects all that information, and then you create a vector representation, and also you actually run through these three different approaches that I mentioned previously. You first apply rules-based, right, and then you apply predictive analytics, right, and then thirdly you apply this new vector-based detection method, and see if you are able to actually improve that detection accuracy, right. So the control function I'm talking here from 1.3 to 3.0, it's like this kind of like runs through all those checks and balances to ensure you have a better detection accuracy here. So when you think about like modeling this in a MongoDB, right? So the reason why MongoDB is so powerful is to collect all that information, right? Like as a consumer, as a shopper, trying to do purchase something online, all the data, right? It is it's not very structured and it is not constant. Clickstream data is not constant. You don't know, one customer may actually click 2 pages of your website and the other may actually just straight away go to the shopping cart. So you cannot really predict the clickstream path or navigation path, right? So it's very unstructured, it's very unknown. In situations like that, you need a flexible document model that can actually progressively, you can actually build out, right, as you ingest more data. So this is an example showing how you can actually use MongoDB document model to kind of ingest all that ever-changing data. So the other important thing you can see on this slide is that I have both operational data, clickstream data, coinciding or collocated with the vector data. So in other words, like both the vector data and your operational data are collocated, right? They're in the same collection or the same document, right? That's the beauty of MongoDB. So you actually, by doing that, you actually bring a lot of efficiencies, both developer efficiency and also performance, and also, and you can actually get your products out to the market very quickly. So now, when you think about like creating this massive high-dimensional vector around this shopper that this developer is trying to help, right? How do you do that? How do you generally do that? So what you do is like you use what we call a vector template. And I'm not going to go over like what is a vector template or a embedding template. There are a lot of YouTube videos on that. They have actually done a better job than I do on this stage. But I would strongly recommend why you need to use a template to actually do a vectorization, right? Templates actually, at a very high level, they actually give a structure to data ingestion, which is crucial for two reasons. The first one is like it gives a security. I'll tell you a security why. And also it actually helps you with performance improvement, right? So the prompt engineering and vectorization are their costly actually activities, right? You wanted to bring a lot of standardization there where possible, right? To actually reduce the cost incurred on that. So the reason I'm showing this is this is very relevant for MongoDB. When you think about the document model, you can actually create these templates very easily, right? You can actually create a template in a JSON, and then actually you can update this template as you see a new data if you wanted to add a new data here. So for example here, I have like a T0, T1, T2. What I mean by that is like each of them has their own schema. For example, in a payment transaction, I have ISO 2022 schema that actually takes all the ISO 2022 specific data into that schema, and a Swift related one, we actually segment that separately, and so on and so forth. And also you can actually add all clickstream data, and maybe in future if you have another data source that you want to add, or maybe you want to have like a dashboard, one of your case management team, they want to dynamically add a new data source to this, they can actually do that. The template is going to pick it up, and you can actually create these vector embeddings live, right? So in real time. So again, what I'm saying is, doing this, right, and you can actually prevent anomalies very easily without having to actually go back and do some kind of a batch analytics and train your models like periodic intervals and all that. So with this, you can actually bring a real timeliness to your solution. And here, what I used is OpenAI embeddings. You can actually bring your own embedding software. In this example, we just happen to use the OpenAI embeddings. And now, like if you look at the backend code, right, code view, this is how a transaction looks, right? A good transaction, like as I said, like there is a fraud vectors, an array of objects, and there is that fraud flag there. It's a 0 because it's not fraudulent. That's how you would see like a good a transaction object, right, with both operational data and vector data with the flags around the fraud or not fraud. And a bad actor, right, somebody who's actually trying to steal money from this good shopper, right, and is a data representation looks something similar to what you see on the bad actor slide here. And now, so how does this work? And I told you like you can actually collect this information. Generally, developers, they collect this information like in a sequential manner or in an asynchronous manner, right? And get all the data and collect the information as the shopper browses through this thing, and send all the data to this OpenAI, any type of embedding software. You don't need to use OpenAI, but you can use your embedding software of your choice. And then you create a vector, and now you have a payment vector. Payment vector now is not like a one-dimensional or two-dimensional, it's a very high-dimensional vector, right? It has all that information. including the information. Like I said in the example, like any type of a social media data or any type of a negative news, right? And you can actually ingest that and create this a vector. That's the latest and greatest. And then you actually search that vector against previously actually saved fraudulent transactions in your database, right? And you check that and see if that incoming transaction actually is within that like a threshold. You can actually set your thresholds in the programmatically. One of the examples used, our developer Paul used here is a voter algorithm. Like in that, like X% of a payment neighbors are in a high risk, right? And you can actually say then the payment is likely to be in that high risk class, right? So that's how you classify, well, this transaction may be a fraudulent one. So once you do that using a vector search, you can actually block the transaction and you actually help your shopper with losing money, right? And thereby helping organizations, right? So we have an example solution that is actually posted on our GitHub. The example solution is, I have a slide on that. You can actually take a scan or barcode to get to the code. So the example solution, we have a big vision for the solution, right? And we started very small, and we have actually used only few parameters, although I have showed you number of parameters in a previous screen, like how you can actually ingest different sets of data. For showcasing the vector capabilities, we picked only few, a select few of those parameters, but you can apply this. I mean, you get the idea, and you can actually apply this to your situation. And when you actually set up this demo on your environment, the demo workflow looks something like this. You go there, you log in your user ID password, and then you'll land onto a dashboard. In the dashboard, you have your previous transactions. Right? This is a slimmed down version for an online shopping site. We don't want to get into the whole 9 yards in creating the e-commerce site. And we created a simple mock-up with the necessary functionality to demonstrate what we want to demonstrate. In this case, how vector search can help, right? So you go there and you can see that. And when you have a good transaction, happy path, and this is a kind of a user experience you see on the screen. And when a transaction is actually not a fraudulent, like I said, behind the screen, so there's the code I was showing you previously. This whole data ingestion and vectorization and classification of that vector searching against the existing fraudulent transactions done automatically, and it gives you that result out on the screen depending on the message you receive, right? And if it's a fraudulent, you see that message like here. And in this case, like there's a transaction that is blocked for a fraudulent behavior, right? So I'm going to leave this to you, and please check our GitHub. So now we talked about a fraud. Like I talked about only a credit card fraud, and you can apply that to a debit card, or even like a check fraud, any type of a fraud, or not even a fraud. You can actually apply the same concept to any type of a transaction monitoring, right? Where you see high dimensional data, and that you cannot really train your traditional predictive models, right? But you wanted to still use that real-time data to kind of find anomalies. So now how you can actually extend this to anti-money laundering, right? If you think about it, anti-money laundering is slightly different, right? So let's consider an example. The shopper example I'm giving you, like there is this a good shopper who wants to actually make a purchase on a website. He does some purchase, but imagine this shopper actually became super rich over the years, right? And this shopper wanted to evade taxes, right, in the US, right? He doesn't want to pay taxes, just a hypothetical situation, right? And what he does, like similarly in the AML space, right, what they typically do is they actually create like what we call synthetic identities, right? They create a synthetic identities, and they actually funnel the money to some offshore accounts, right? Let's say, for example, they use a real information as well as a fake information to create a synthetic identities, right? A situation like this, right? For example, I'm going to give you one example here, right? So, for example, on the left you have the payment initiator. On the right-hand side, you have the actual beneficiary of that transaction. But in this case, right, what they do is they create the beneficiary in some cases. In this particular example, when a shopper who became like evil wanted to save money from the US government and not paying taxes, he created maybe a fake account, right? So now how do you actually determine if it is a fake account or not, right? Traditionally, what we do is that you try to compare first with their, like a physical address, right? The street name, zip code, and all that. Sometimes, in most of the cases, it does match, right? If it matches, it's a low risk, right? And some cases, like you can actually check with their personal details, right? Multiple personal details. If it is like a matching, multiple personal details, it's a medium risk. It becomes a high risk when the payment initiator profile is actually matching to the beneficiary details by the means of like biometrics, right? Maybe facial recognition, maybe deep fake, right? And these are the things that they use to actually do this fraudulent transaction, or maybe simple email address, right? I mean, this guy who's on the other side of the country, he's not physically there, but he had created an account, and if he uses the same login information to log into that other account, right? And you can actually flag that can be a fraudulent transaction, right? I hope you understand the concept here. Like, so doing something like this, right, where you have a very complicated relationship between different actors involved in this payment transaction, right? It's not just one-to-one, right? And you may have like a one payment sent to like multiple guys, right? And those multiple guys, they may send the payment to one beneficiary at the end of a day. This chain can go on and go on, like a linked list, right? And you cannot really train any type of predictive modeling in scenarios like that. It's very hard. It's very hard to train, right? And that's the one reason, like these days, they're using a Gen AI to actually create synthetic data to train these predictive modelings, right? So you cannot really predict that using predictive analytics efficiently. This is one use case for vector search, right? The vector search you can actually, like I said, like how you can do that using a vector search, right? And like I said, like the same concept here. And you apply the same templated architecture here, right? And you ingest the data, and you actually get all the payment transaction from start to finish. All these transaction-specific, identities involved in this whole structure, and all of the relevant data. And also, you can actually capture a negative news about these participants involved in this transaction, right? There may be a negative news just surfaced on CNBC or somewhere, right? And you can actually get an RSS feed and get that into operational database like MongoDB and use that information to actually, find if it is a fraudulent or not. So if you think about it, it is actually it's a pretty phenomenal, right? How you can actually use structured, unstructured, and semi-structured data as you actually secure new data sources, as you add new data sources, and also as fraud patterns they emerge, right? Like something like a deepfake, right? You can actually address that real time. Like I said, you can actually, once you have the data in place, you can use any type of embedding software, right, of your choice. Like I said, like in this example, we just happen to use OpenAI. Now, so what's the difference between previous approach and this one, like the previous card fraud and the anti money laundering? So the only thing is, like, we are adding a new dimension to this thing. Is the transaction parties involved, right? Not just like one persona. Previously, we tried to actually protect one shopper, so there's only one shopper involved, maybe merchant on the other side, right? But the one shopper profile, you actually do all this, vectorization and creation of a highly dimensional vector based on one profile. But you now have like multiple parties involved. There are multiple counterparties involved in this transaction. So you actually try to use that relationship data also here to kind of prevent a fraud here. So the same thing, like card fraud, like the same approach. Like I said, developers they never give up, right? developers like you and I, they to actually improve their solution, right? So we started with risk 1.0, and we went to risk 2.0, and then we went to risk 3.0. What else we can do? Because we're still losing money, right? We're still losing money, a lot of money, and also like I said, not just us, not just as consumers, banks, financial institutions, and governments also losing revenue, tax revenue, right? If somebody is actually evading taxes, it's a loss of a tax revenue for us. So how can you actually improve this performance, right? So developers like you and I, and even like our developer Paul, what he's trying to do is he's trying to use RAG architecture, in that he's actually going to include large language models in this architecture, right? Like how let's say you have detected a fraud there, and there's a fraudulent transaction, right? How do I actually use that fraudulent transaction and verify that using a large language model, right? So large language model, as you know, this can be a proprietary large language model that you want to train, especially in a financial organization, right? You train your own model, right? And you train using your domain data and your historical transaction data, and also fraud case studies and a variety of the data specific to your business and specific to your company, right? You train it and use that model, and also you actually combine that information with any type of case management, right? So if a fraudulent transaction, when it happens, right, generally, like you said, some of you said like you were a victim of a fraud, card fraud in the past, right? Like generally you get a SMS message that said, well, is this a legitimate transaction or not, right? So that kind of information, like the customer service, the call goes to customer service, all that back and forth between this shopper and the customer service is actually logged into a system, right? You can actually use the data, right? The transaction data, text data, or maybe video data, and actually further improve the accuracy of your large language models and your prompt. You can give a better context to your there. So this is how you can actually, include large language models and RAG architecture in the ecosystem here to actually further improve the accuracy. And now, so we talked about how developers, they're constantly and relentlessly trying to actually help organizations and the consumers and the governments by creating these amazing software solutions, right? Intelligent software solutions, right? And like there are different things I talked about. If you want to see like how all these things fit together in an end-to-end architecture, this is how it should look like, right? So now that brings to our today's conversation actually, why vector search, right? So vector search is a super important, like because this is a foundational step to any type of applications, right? So you can actually build intelligent applications. So the intelligent applications I just mentioned, you can actually build real-time intelligent applications, right? You can actually beat predictive models, right? Because now you can do this in the moment, and you can store vector embeddings, right, alongside your operational data, right? You don't need to actually buy another niche technology by actually to complicate your architecture, right? And also actually spend a lot of money in buying another license, right? You just need a vector search, and MongoDB supports that. And now, so vector search is great, right? So vector search is something like, for example, you have a home improvement contractor, right? So for him, a flashlight is something is a part of his toolkit, right? To me, in my opinion, vector search is like is a tool, but what developers need is a toolkit, right, to create these amazing intelligent applications, right? In addition to vector search, they need a platform, right? A platform that they can use and innovate and create new solutions very efficiently and elegantly, right? So MongoDB actually provides you that a platform, not just a vector search. It comes with that embedding nature, right? And you have a document side of the document model, how you can actually progressively actually update to things, right? And how you can actually ingest data as you add new data sources, right? And also a platform that actually tightly integrates with the AI ecosystem, right? Because we are not MongoDB is not a large language model company, and you have like companies to actually provide those resources to you. You can actually integrate them very easily. It's going to save a lot of integration costs for your companies, right? And using a platform like MongoDB, you can actually create these amazing applications, right? And like I said, developers spend a lot of time, and they relentlessly try, and you have to actually thank them, and you thank them by giving them a good a platform that they can actually use to create these amazing applications without having to spend a lot of time in trying to figure out the basic things, right? So MongoDB developer data platform, right? The other advantages with that, in the fraud and the AML space, generally, like I said, creation of a single view around a customer or a parties of customer or a transaction are crucial. We have a number of use cases that companies used in the past to create these operational data layers. And you can bring real-time nature to your applications, right? You can bring real-time data. And yeah, so there's other use case. So here's a set of resources that you can leverage. Risk 3.0 fraud detection solution. Like I said previously, one of our developers is working on it, and we started small, but we are planning to expand the solution in the next couple of months. And as we add more updates, and we'll update our GitHub. But right now, the basic alpha version is available on our GitHub. Please take a look and and see if that is of something used to you. And we have financial services, latest papers and webinars. There's a link to that. And like I said, a card fraud solution using a Databricks that we did previously, Risk 1.0 and 2.0 solution is actually is available on GitHub as well. You can actually go and please scan the barcode. This pretty much brings me to my last slide. And if you like this session, please give some feedback. I have like 5 minutes. I may be able to take questions.
Does anyone have any questions?
I'm open to take your questions if you have any questions.
Please raise your hand. There you go. Shiv?
Oh, this one?
Hi, this is Hari from JP Morgan.
Hi, Hari.
Yeah, hi. And my question is like adding these vector embeddings as part of the, when storing the operational data, how performant is that, right? Like what is the latency that it introduces?
Well, definitely, as you know, like adding a new parameter comes with a little bit of latency, but I don't think in the grand scheme of things that will have any negative bearing on your outcome, right? Because you're doing this for a reason. The reason is to actually improve your detection accuracy, right? But definitely, I don't think it's like a seconds. It's like a sub milliseconds, right? MongoDB platform is just phenomenally fast, lightning fast. But we haven't done actually any benchmarking on that. But I'll make a point to actually get some benchmarking done on that, and then we'll update our GitHub so that you get exact information.
Any other questions?
So when you're applying your vector search, you're matching the data with the transaction data, the current
Previously.
transaction data with historic transaction data,
Correct.
right? Are you applying AI on top of that? Or how is it different from any rules-based
Yeah. Good question.
match? Because you could do the same thing without vectors.
Brilliant question. Yeah. So, if you remember, like I said, the 3 stages to preventing a fraud. You first, by default, you apply some rules because the rules are set by a consumer, right? When you go to a website or something, like you sometimes can specify transactions per a day or a transaction. Apply all those, and you still apply the predictive analytics, right? Right, and you still actually wanted to improve performance, right? I mean, when you actually still have a doubt, I mean, programmatically you assess that, and it's just a probability, right? It's like with a 90% or 95% probability, you can actually think this is this is a fraudulent transaction, but you want to make sure, is there still a cross-validation I can do? That's when you use a vector search. So you apply all those, and then you apply vector search, right? And hoping that the vector search, based on your previously classified fraudulent transaction, it gives you a better result, right? And you're not stopping there. Like I said, you're not stopping there, and you further try to actually see if a RAG architecture, I mean, leveraging large language models trained using your domain data may actually give you a better result. It's not like it's kind of like a multi-modal approach, right? And you need to actually use multiple techniques to actually filter this fraudulent transaction. One approach doesn't work. Did I make sense?
So this is kind of extension to his question. I understood there is a machine learning and AI involved, but I'm still struggling to find out how it is Gen AI. Like, what are you generating? Are you generating synthetic data or
Yes.
simulating something? So can you just elaborate on that?
Very good question, yeah. So Gen AI, in this example that we have, the example solution right now, in the current state, is not using any Gen AI, right? Gen AI, we're not generating anything, right? Like I said, that's always been my approach, and I always start small and see if the results I get with the basic technology is good enough, then I'll stop there. If I'm not, I don't want to unnecessarily throw some technology stack there because it's available, right? So if you think about it, right, Gen AI basically at foundational level, it uses vector search. All AI platforms requires a vector representation, right? Right, even if you send some text out to GPT-4, it first does that vectorization, right? The text to vector, right? So vector is the core ingredient, right? So vector, like MongoDB vector search, actually comes with the nice nearest neighborhood type of search, and that is what I'm using to actually find out. I'm not doing, this Gen AI, but like Gen AI is what I will be doing in the improved model. Like you see, like the last slide I showed you, that's where I said we would use a RAG model, RAG approach, right? How do you enhance the current solution to use large language models? Again, the large language trained on your company specific data and your own heuristic data, right? So that's like a next step. And we are planning to do that, and as we actually make these updates, and we'll actually post this code to GitHub. So the most important thing is this, right? Yeah, you don't want to create technical sprawl again for the sake of using a technology. I mean, right? I mean, like, so you see a need and you see a benefit, and then you actually use that. Like do that like in a progressive way, in a like a methodical way, in a more scientific way.